Okay, so if you study statistics, you want to know what it is. Okay, so here's the definition for you. Statistics, right, is a science of planning, obtaining, organizing, right, summarizing, presenting data, pretty much, and then drawing conclusion based on the data. So as a subject, it is the, I would say, the entire process of research. We use stat to do research. There are two types of statistics. One is the descriptive, and the other is differential. Okay. Descriptive, just what it says, describes. So if we just describe data, summarize data, then we just do a descriptive. But if you want to draw a conclusion, then we have what we call the differential statistics. Draw a conclusion, you're making inferences. So the first half of the class will focus on descriptive, and the second half of the class will focus on the differential. Okay, so there are two types of statistics. So let's start with this terminology here. The word population. Now, if you do a study, you want to know what you want to study. So is it people, is it objects, is it events? Okay. That is the population. Sample, on the one hand, is a subset or subgroup of the population. Most of the time, we're going to study only the sample, because it is very hard to obtain the entire population. Let's say I'm targeting the entire US population. Well, that's a lot of people. Okay. So the best way to do it is just take a sample. Let's say I target people in a college, student in a college, right? Again, there's still a lot of students. Okay. Let's say I will study a biology student who major in biology, right, in a college. Even then, it's still a lot of people. So the best way to do it is take a sample. Take like 10 students who major in biology, or 100. Okay. And from there, we can draw a conclusion about the entire student, or the entire population, meaning all the students who study biology. Okay. So data is what it is what you want to study about the population. So it is they call it characteristics of a population. So there could be height, weight, so anything you want to describe the population, that's just It's just that it's just the data. Now, these are two terms here. Okay, another term for it, right? This is the statistics. Well, we have two definitions, right? So the first one is the subject as a discipline, right? Subject. And then the other definition is what we use the most. Now when we talk about stat, we normally meant the numerical measurements. Remember the commercial stats that, right, in the football? Okay. It means show some number, okay? So we think of stat, we think of numbers that describe something. Okay? So parameter, similar to stat, but parameter describes the population. Okay? Statistics here describe the sample. Okay, so that's the difference between the two. There are two types of data. Okay. First, you can see there's the quantitative data and the qualitative data. The first one here has to do with the quantity, the numbers. The other one is the qualitative data is going to do with the identifications, okay? Identification of a population. So one has number, one does not. Okay. Quantity, right? Quantity is how many, how often. Those are numbers. Quality, right? The quality of a something. Good, bad, right? Average, above average, things like that. Okay. For the numbers here, we can divide into two types of number, okay, pretty much. Discrete and continuous number, or this case data. So quantitative data divided into two types of data, okay? Discrete data and continuous data. Okay. Discrete data are data that you can count. Okay. Continuous data are data that you can measure. So like example of discrete data, like number of people, right? Number of oranges. I count 1 oranges, 2 oranges. I count 1 people, 2 people, 5 people. Okay. Measures are things like I measure the weight, right? I measure my weight, I measure my height. Okay, those are height and weights on example of a continuous data. 5 inches, right? 5.2 inches, things like that. Or 6.5 feet, things like that. Okay, those are continuous data. The thing is that it is good to know what type of data that you have, so that it calls for certain research types. Okay, so that's why we need to know what kind of data that we have. Another way to look at data is look at through the level of measurements. Okay. So we have this nominal level and ordinal level. The first two are pretty much the qualitative data. Okay. About quality. So like nominal, it just said that you just name. Okay? You just, I guess, label. Okay? With no particular order, right? With no particular ranking. Right? This is a very simple one, very simplest. I guess the probably simplest one, right? Simplest level, it just name items. Like color, right? Gender, right? Red, blue, green, yellow. Okay. Country of origin, right? Those are nominal level. Ordinal is another level that with just name or label, now we have label with some certain order, right? Like good, very good. Poor, very poor. Now we know that poor is probably different than very poor, right? I mean, good is different than average, or good is different from very, very good. So these are ranking that we know. Okay? Like your grades, A, B, C, D, F, right? Those are ordinal because A is different than B, right? A is higher than B, B higher than C, C higher than D. Okay. All right. Those are the two first nominal, first level, and then the last two is going to do with the quantitative data. Okay? Quantitative data. Interval and ratio. I give you guys two point of differences. Okay, so the first difference is that interval level do not have a true 0 point. Ratio level does have a true 0 point. Okay, and then interval level cannot compare two levels of interval values. Okay, ratio does. You can compare two ratio values. Okay, for example, like a person with 1,000 pounds and a person with 100, sorry, person with 200 pounds versus a person with 100 pounds. Now, we know that 100 pounds is, I guess, half of 200, right? Or 200 is double 100. So now we can say, we can compare, right? We can say a person with 200 pounds is twice as weight as much as 100 pounds. You see, now you compare the two. Now for the interval level, let's say this is a 40 degree Fahrenheit, okay, versus 80 degree Fahrenheit. So we know that 80 is twice as much as 40, but when it comes to temperature, okay, we cannot really say that a person that located at or something located at 80 degree temperature versus somebody that located at 40 degree temperature, we cannot really say that the person with 80 degree temperature has more heat, right? Double the heat of the person with a 40 degree temperature. Okay. And besides the difference, besides the molecules, right? You cannot really measure like double the molecule, you know. And we cannot really say that or measure it. and also the person who feel it, right? I mean, how do you feel something is as twice as hard as the other? I mean, that's tough, right? I mean, how do you measure something is twice as hard as the other? That's tough, isn't it? So temperature in Fahrenheit is example of interval level measurements. Okay. The weight is example of ratio level measurement. So like kilometer, right? Gram, miles, or those are ratio level. So most of data are ratio level. Okay. Limited example or interval. So they give us the measure temperature in Fahrenheit degree. Okay. Another example of interval level is like the year of birth. Like I was born 1981. Okay. Somebody was born 1990. Now, the year itself means nothing, right? It's just the label of this is the number that you were born, 81. This is the number the person was born, 1990. Okay. You can compare the difference between 90 and 81, but not the year. Well, you can compare the age of the person who born in 1990 versus 81. You can compare the age, but not the number. Okay, so that's why it is interval. Okay, so that's that for the data. Now let's talk about what kind of study you want to do. Okay, so on the basic level, we have two types of study. Okay, first is the observe, or it's called observational study. The other is called experiment study or experimental study. These are really basic. Okay, observational just means you observe, right? You just dare to observe the data. You don't do anything to the subject. Okay, so we just dare to observe. Like if I'm a study chimpanzee, right? I go to the forest, I observe what they do. Right? I don't play with the chimpanzee. I mean, that's obvious. I'm just recording what they do. Okay? It will study some. It will study a ceremony. Right? Those are things that you go there observe. Okay? You don't apply anything to the subject. If I study the past, like the H1N1 virus in 1918, see, I studied those past. I just study the record, right? I don't not go there and apply anything to the past. Okay. Now, experimental study is just pretty much what say experiment. So you give something to the subject. Okay, you give some treatment to the subject. Like half of student have tutor. Okay, half student do not have tutor, and they both take the test. See. So the treatment is the tutoring. and see how both do on the test. Okay. Those are another example of a experimental study. Okay, those are the basic level of study. And then last but not least here, we talk about how to collect data. Okay, how to collect data. Sampling method. Sampling methods, the word sampling means, right, sample. So you take a sample, well, you do the sampling. So that's kind of what it says. So sampling method. How you go about collecting data, collecting the sample. Okay? How to go about collecting sample. This is what we call sampling methods. Okay? The first one is just simply called the random sampling. Okay? The idea is that everybody has equal chance of being selected. Okay, that's the idea of a random. Like I put names on hats and I just select couple. Okay. Well, of course, without looking at the name, right? I just put everybody's names on hat and just select 5. Well, when you select like this, every number, every name in the hat have a chance of being selected. Okay, so that's very easy idea. The other one is called the convenience sampling. It just means that it is convenient to take the sample, okay? And you don't really care if everybody have equal chance of being chosen, okay? Like, for example, like internet poll, right? I have my YouTube channel, right? I take a poll in my YouTube channel, and that's it, right? Or I have a radio station show. I have people to call in and give them answer to my questions. Okay. No, I don't really care if all the, well, I don't really care if people comes in or not, right? If they come, then I got their opinion. If they don't, then that's okay. I don't really, right, worry about that. Okay. Now the other one is called the systematic sampling or systematic random sampling. Like we take one of every 100 people. Let's say I stood in the library, right? I'm gonna know student who comes into the library. Okay, I have the survey. I want to know about the library. Okay. So I don't talk to everybody that comes into the door. Okay. I'll talk to like every 5th person. Okay. So whoever comes in, my don't have equal chance of being selected. But I just chose every 5th person. Okay. Or if I do a guest lecture and I have a survey about my lecture, then I can just survey every 3rd person that comes in. Okay, so those are, in a way, it is a systematic in the sense that you have every fifth person, every 10% that you want. Okay. Now the last two here is kind of strange, but the last two is called the stratify sampling and the cluster sampling. So if you read this, it says, right, in the stratified sampling, population is divided into number of groups, subgroups called strata. And then within each subgroup, a sample is taken from each of them. Okay? With the equal size, put that way. So see, example of this, if I say I'm gonna take a poll about the presidential election, right? So I'm gonna know about Democrats, I'm gonna know about Republicans, I'm gonna know about independents, right? So those are my subgroup. Okay. The entire group I have is the entire population of the US, right? And most of us are, I guess, we have to label as Democrats, Republicans, or independents. These are large subgroup. And from I would take, let's say 1,000 Democrats, okay, 1,000 Republicans, and 1,000 independents. See, each of the group, I have a sample from each. Okay? And then they all have the same number of people. Okay. That's how stratified is. Now you can take, like, say 100 people from Democrats, 50 from Republicans, and 50 from independents. But if you do that, then your state will not be good example. Okay, because you get more Democrats than Republicans and than independents. So that's what we call here is proportional to the size of the subgroup in population. So you got to be fair, right? You got to take, if you take a sample from Democrats, Republicans, and independents, you have to take same number of people, okay? To be fair, right? Because if you don't do that, if you take more Republicans, then most will say you're gonna have a poll that show that most people prefer the Republicans. If you take more Democrats, then well, the poll will show that more people will say Democrats. So that's why we don't want to do that. Okay. Each sample you have the same number of people in there. Okay? Now the other one is this cluster sampling. Very similar to this stratified sampling, just that this time you can take the people to the population and put it into a cluster, okay, or subpopulation. And then from those subpopulation, you're gonna select some of them, okay, some of the subgroups, some cluster. So here saying that researcher usually use the entire cluster for each cluster chosen. Okay? So for example, say I have, let's say I'm gonna know about math one, say biology student in a college, right? Say for the spring of 2022. So I have say I have, let's say I have a 10 section, say I have 10 classes. So I have, say, let's just say, well, let's say 5. So we'll say 1, 2, 3, 4, 5. Let's see, I have for me, see, I have 1, 2, 3, 4, 5, 6, 7. So these are 6 classes that the school offer, okay, for biology student. So each classes or each section will be my cluster, right, for the entire school. So my population is the student who major in biology for the spring of 2022. Okay. And they offer 7 classes, right? So here, all I have is 7 classes, 7 classes that are biology classes, okay? But normally I want to take everybody. I want to take all of it. I will take all 7 classes. But I don't have time, right? I don't have time for all 7 classes. So, right, 7 classes on my population, okay, because those are biology student. Okay, I don't have time to talk to everybody on all 7 classes. So what I do is I want to put this in hat. I will say I will put number 1, 2, 3, 4, 5, 6, 7, and then I will select. I will pick, let's say, 2. So I only have time for 2 classes. Okay, so I'm going to pick. Let's say I put those numbers in a hat, and I draw. Right, I got number 3, and then I got number 7 and number 6. See, now each class have equal chance of being selected, yeah, because I put in hat, right, and just draw. If I draw 2 classes at random, see, so I got class number 3, class number 6, and those 2 classes will be my sample. Okay, I'm gonna go to those 2 classes, and then I will take everybody in those, every student who took those 2 classes. That is my sample. Okay. So what's the difference between those 2? Well, right, 7 groups, you only took 2 groups. Okay. Here, you have 3 groups, but then you don't take the entire 3 groups. You take some of the groups, right? So you take 1,000 here, 1,000 here, 1,000 there. So you take 1,000 D, 1,000 R, 1,000 dependents. See? Every subgroup have a sample. Okay. Here, some subgroup got a sample. Okay. The rest do not. You see a difference there? Or let's say I have 3 classes. So I have 3 classes, right? So I have, let's say I don't offer 3 classes for the biology student. Okay. Right. So class 1, class 2, class 3. Now for the cluster, if I wanted, I can just go ahead and put 1 filtering hat, and just draw one class. If I draw one class, I got say number 2. Okay, and then I only go in and then survey all students in class number 2. I don't care about number 3 or number 1 class. Okay, that is a cluster, right? But for a stratify method, I go to each classes. Okay, I go to class 1, class 2, and class 3, and then take 5 students out of class 1, 5 students out of class 2, 5 students out of class 3. You see, so that each class have some of them to represent my data. Okay, there's only difference between those two. Okay, any questions for this? All right,